Okay, Newton's laws, number 4. This is where we really got to put these laws into action, right? So, let's get my scratch paper ready. Alright, so let's do A. Let's do A. So we see an object. We got to identify all these things. First off, this, just for future reference, is net force. Remember we talked about this earlier? This is our overall force, right? Okay, so from our diagram, we are given one thing, force of gravity. And it is 600 newtons down. So, we only go on our diagram here. We don't go off of anything else. So according to our diagram, the net force is 600 newtons down. We don't add other forces because they've done it. Remember, this is already done. All right? So, now we got to find everything else. We got to find the mass, acceleration, yada, yada, yada. So we know that, we know that force equals mass times acceleration. We know that our force is 600. We don't know our mass. And if they don't give us any kind of acceleration, we're just going to assume the acceleration of Earth, 9.8 meters per second squared. So, with that being said, let's do it in the calculator. We know it's multiply here, so we got to divide by 9.8. Divide by 9.8. So I'm going to do it on my calculator. 600 divided by 9.8 equals 61. I'm going to flip the mass, so the mass on the left side now. 61.22. So now we have our mass. 61.22, right? Our acceleration, we know is just 9.8 meters per second squared, and we know it's down, right? Because they tell us it's down. Cool. So that's easy. That's not even hard at all. So we knew that. Pretty simple, right? So let's do B. Let's do B. Let me get my calculator. It just fell on the ground. It's actually my phone. Yeah. So, line through this, we're on B. So we're given two forces. 200 newtons up and 600 newtons down. Okay? So that means you can do this in your head. The net force, the winning overall force, is 200 newtons down. Right? The reason being, because look at it. If one person's pulling, if you turn it sideways, I mean, piece of cake, right? Turn it sideways. If one person's pulling with a force of 400 newtons to the left, one person's pulling with 400 newtons or 600 newtons to the right, well, it's going to move to the right with a force of 200 newtons, right? That's the difference. So that's all we do in that. Okay? So that's actually pretty simple first one. So we're going to put 200 newtons down because it went down, right? Now, we got to figure out the mass / acceleration, okay? Okay, so let's figure out the rest, okay? So, in this case, let's find the mass. The mass, there's still a downward force of gravity of 600 newtons, just like this one. So in this case, the mass is going to be the same, 61.22, okay? This is where it gets a little tricky, okay? Before even figuring out the acceleration, we know that it's going down, right? Overall, because the overall net is down. So we can just put down here. Now, it's not accelerating down. Think about this. If there's some lift, let's say you jump out of a plane and you're holding on to 100 helium balloons, right? Not enough to make you float or go up, but it's going to slow you down, right? So your overall acceleration will be down, but it's not going to be normal Earth's gravity, right? So we can't just put 9.8 here because we wouldn't be right. So what we're going to do is we're going to look at our net force. Our net force is 200, right? 200 newtons. N's look like W's. And we know it's force equals mass times acceleration. And we know the mass is the same because this is a product of the mass. So our mass is, I'm going to rewrite it, 200 newtons equals 61.22 times acceleration. So now we know we just got to divide that out. Because, again, remember, it's not acceleration of gravity because something's slowing it down at a rate of 400 newtons up. So it would be like if you jumped, maybe you jumped and grabbed a hold of a rope, like one of these kind of deals where there's a rope and then it's attached to a little like lever deal, and this is attached to a weight. If you jumped, you're going to go down, the weight's going to go up, but the weight's going to slow you down, right? Same concept here. The thing's going down, but it's getting slowed down, so it's not going down at normal gravity speed. So anyways, I digress. So let's do it. Or let's see, 200 newtons divided by 61.22. So you should get something like 3.27 meters per second squared. Awesome. See? So this part, tricky-ish, piece of cake. Good. Good, 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 good. So, got the rest. Remember, if it's something like F, well, don't worry about it. Don't be confused because there's a million forces here. If you're used to up and down, since the ones we just did were up and down, look at F, turn it sideways. Bam. Now your up and down is this, right? So don't be confused. I'll give you a pro tip for F. The net force is not up and down because that neutral's out, right? The net force is right. And if we look at the difference between these two, it's 16 newtons to the right. So hopefully that helps you guys out. Yeah, so there you go. All right, guys, if you got any questions, let me know. You're going to do great.